Hi guys and welcome to the video. In this video we'll set up some network iSCSI targets, allowing us to have computers connect to this network storage but think the drive is local. So let's get started. Hi guys and welcome to the video. Setting up an iSCSI server. So why do we actually want to do this anyway? Because we're all used to mapping a network drive to our PC so that we can save files on our network storage. It's great and it's really useful. But as well as its advantages, it does have disadvantages too. Now the advantages are obvious, just sharing files with lots of different users and computers. Now the disadvantages, they're not so obvious. Well, not until you come across them anyway. Have you ever tried to install something on your map network drive and it doesn't let you, saying you must install it on a local drive? This is often the case with some games. For example, Blizzard games can't be installed on the network drive. When you try, you can't even see the map drives as an option. Also, things like Dropbox on a map network drive, it just won't work, because the network file system doesn't send messages when files change, so Dropbox can't work properly. So, this is what an iSCSI target is for. It allows us to connect what the computer sees as a physical hard drive to our PC over a network. It basically carries scuzzy commands over a TCP IP network, allowing us to map to the block storage, so our PC thinks the map drive is local storage. Now, this may sound great, but it does have drawbacks too. So we must know when it's best to use iSCSI and when it's best to use normal file sharing like Samba, etc. Now, things to think about when choosing whether or not to use iSCSI is mainly that iSCSI can't be connected to more than one computer at once. Well, it can physically be, but just don't do it because it's going to go horribly wrong. The problem with two computers writing to the same iSCSI target at the same time is that one computer doesn't know what the other computer has written, as the file system isn't a network file system, so one computer can easily overwrite the data of the other due to this split brain situation. So because of this, an iSCSI target should only be used with one computer at a time. But yes, you can actually disconnect it from one computer and connect to another without any problem. So iSCSI will give us access to the space on our server as a local drive, but it's just not shareable. So by default, unRAID doesn't support iSCSI. So in this video we're going to set up a VM of Openfiler, which is an open source network storage solution, of which we'll use the iSCSI target part. So when we make the VM, we will map the drives that we want to use as iSCSI targets to the VM. We can map either physical unassigned drives or vDisks we create on the array. Personally, I think it's a really good idea to map a QCOW2 vDisk, and this is because with a QCOW2 disk you can set the size of it, but it won't take up all of that size until the space is filled up inside of it. Let me just show you what I mean. So if you see my cache drive here, it says I've got 225 GB free. So now let's just go to the VM manager and I'm going to click on Windows 10, and here I'm going to create a QCOW2 disk and I'm going to make it 200 gigs. So you'd think that would fill up pretty much the rest of my cache drive. And you can see I've still got 225 gigs free. Now if I have a look at the files, I made it in this QCOW test folder here, and you see that the file is only actually 200 kilobytes because there's nothing inside. So QCOW2 disks are really useful, I think, for using as iSCSI targets. So let's download the Openfiler image. Just do a search in Google and then click on the link. And that will bring us to this page where we just click on Download Openfiler Free and click this button here. So once it's downloaded, put it in the ISO folder so you can access it from the VM manager. Now we're going to create a new VM and we'll base it on the CentOS, because I think that's what Openfiler is based on. And I'm going to name my VM iSCSI, and I'm going to give mine 4 virtual CPUs. That's probably too many and you can get away with a lot less. And memory, I'm going to use 2 gigs. And very important, make sure you set the BIOS to CBIOS. And then let's choose our install ISO, which we just downloaded and moved across. And now we need to choose the primary vDisk size and make sure that's 12 gig. And the primary vDisk bus must be SATA. And everything else here, just leave it as default, although we will be coming back here later, well in the XML anyway, to change the network adapter type, but we'll do that in a bit. So just click on create and then the VM will start to install. So we just go through the wizard choosing our language and then basically then just clicking yes to everything and next, next, next. Choose a time zone and then enter a root password. Then the installation will finish, the VM will reboot and we'll come to this screen here. And it will tell us we don't have networking, and that's because Openfiler doesn't support the VirtIO network driver. So we're going to have to edit the XML of the VM and then find the network type and change this VirtIO here to the model type of the E1000. And then just press update and then we can start up the VM again, and then this time when we get to the page we can see here the IP address that it's been assigned, and we have to log into this through HTTPS and then the IP address and then the port number 446. And you'll see it will say the connection's not private, so if using Chrome just click on advanced and then click proceed to the IP address anyway. And this brings us to the Openfiler login window. Username is Openfiler and password is password. So put them in and then click on to login, and then this will bring us to the system information page. And you can see here's our virtual Ethernet controller that we just edited and put in. But have a look here, you can also see down here that there are no hard drives attached. Well, we've only got our boot hard drive, but we don't have any other hard drives to use as iSCSI targets. So now it's time to shut down the VM again, and then we need to add some extra bits. So let's edit the VM in the unRAID VM manager, and let's scroll down to where it says disks and click on the plus to add an extra VDisk. And I'm going to add two VDisks. The first one here is going to be an 8GB QCOW2 VDisk. Again, make sure you set the disk bus to be SATA. Now I'm going to click plus to add another disk, but this time I'm going to set the disk to manual because I'm going to pass through a disk. Again, I'm going to use a SATA bus, and then here I'm going to type /dev/disk/by-id. And now we're going to have to look up the ID number of the disk we want to pass through. And you can see here I've got two unassigned devices, and the one I want to pass through as an iSCSI target is this Hitachi drive here. But one thing to make sure before you pass it through, make sure you delete all the partitions off the drive, and you can do that in unassigned devices. If you don't have the partitions deleted, then it can't be formatted when we attach it as an iSCSI target. And you can see here that my disk has a label of SDB. So remembering that, let's make an SSH connection to our unRAID server. Then type the command v/dev/disk/by-id/ and then enter. And now at the bottom here we can see the label the SDB, and this is the drive that I want to attach, and the ID number of it is the number in blue here, or the numbers and letters in blue. So let's copy this and then we can paste this into the VM template, and then we can pass through that disk by its ID number. So back in the VM template we just type / and then we paste that number in that we just had from before. Now you may ask, why pass it through using the ID, why not just pass it through using SDB? Well, the letters can actually change on reboot, but the device ID will always be the same, so it's always best to pass through a disk really by using device ID. Okay, so with the VDisks added I'm going to click on update, and because custom edits don't persist when you use the VM manager, I'm going to have to just put in the network adapter again quickly. Okay, great, so that's everything done. So now we can start up the VM and log back into the web UI. And now we can see we've got the extra SCSI device disks here, which I can use as iSCSI targets. But the first thing we need to do is to click onto System, and here we have to configure our network access configuration. So I'm just going to call mine LAN, and then for the network host we put our IP address range in, and mine is 10.10.20.0. But more common IP ranges would be 192.168.0.0 or something like 192.168.1.0. Basically the .0 at the end just means everything from 1 to 254, so long as our subnet mask is correct. And for most of us that will be 255.255.255.0. So this setting just basically allows us to connect to the iSCSI targets from our LAN. Now next click on configure to configure a static IP address, and click here static and continue, and give your VM a static IP. I'm just going to use the one that it is here, but it's important to have a static IP so the IP address doesn't change, because we're going to need the IP address for the connection from our client computer. Also we can put in our default gateway here. So now with our network settings complete, we can click onto volumes, and then on the right hand side click on block devices, and here we can see our disks. And looking at these disks, the SDA obviously is the 12 gig install drive, and the 8 gig one is the V disk, and the 149 gig one is my physical drive. So first I'm going to set up the physical drive, so I'm going to click on SDC, and if we scroll down here we should set the partition type to physical volume, and then click on create. Okay, and now we'll go back to block devices and do the same for our other hard drive. This time it's already on physical volume, so we just need to click on create. So next we need to create a volume group, so click onto volume groups. I'm going to call my first one unRAID 1, and I'm going to assign the physical disk to it. So just click on add volume group, and the next one I'm going to call unRAID 2, and I'm going to add the virtual QCloud2 disk here, and click on add volume group. Right, so now we've got a volume group created, we can now add a volume to each volume group. So click on to add volume, and we can change between the different volume groups by clicking this icon here. So I'm in group unRAID 1, so I'm going to create a volume here, and as this is my physical drive, I'm going to call it physical. And I'm going to move this slider right across to the right to allocate all of the space, and very important, I'm going to change the file system volume type to block, and then click on create. So now I'm going to switch to my other volume group and add volume, and I'll call this volume vdisk. Again I'll assign all of the space and set the file system type to block. Next we need to click onto services, and here we need to enable iSCSI target, and also we need to start the service as well. So now let's go back to the volumes tab, and now this time we're going to click on iSCSI targets, and here we can add a new iSCSI target. Now we don't have to keep the name that's in here, we can change it, and I'm going to change mine to physical. And here if we scroll down we can set various settings for our iSCSI disk, but we can just leave all of this as default. If we change anything we just click onto update to change it. And now we need to click onto LAN mapping. So here we map through to the iSCSI target we've just created. The write mode should be write through, and obviously the transfer mode should be block IO, and then just click onto map. So now I'm going to make another target. This time I'm going to call it virtual, and again click on LAN mapping, and this time I'm going to map through obviously the virtual disk. Now next we have to click on to network ACL, and then just allow access for our network. And also I need to do that for my other iSCSI target, as I forgot to do that earlier, so I'm just going to switch across and then do the same on that one. Okay, so that's it, that's all the iSCSI targets set up. Now I'm going to go across onto my Windows box, and then we can connect to the server. Okay, so on Windows, let's go to the control panel, and then go to administrative tools, and then here you'll see iSCSI initiator, and I'm going to send that icon to the desktop. So let's click on the icon. Now we want to click onto discovery, and then click discover portal. Then now we need to put in the IP address of the VM, and mine being 10.10.20.34. So now we select targets, and here you can see the two iSCSI devices that have been found. And so all we need to do is just click on connect onto each one, and then click OK. But if we go to my computer and look at the drives, they won't actually show up there as yet. So what we need to do is go back to control panel, and then administrative tools, and this time click on computer management, and then disk management. And now here we can initialize both of the disks. And now we can format them. So as you can see, it's actually the computer that we're using the iSCSI targets on that's actually formatting the disks. And next I'll format the second disk here, and also I like to label both of them, the first one physical and the second one virtual. So now we've formatted these disks, we're going to be able to see them under this PC as drives, and here they are as D drive and F drive. Right, so now I'm going to run a test. I'm going to copy this Windows 10 ISO image across. It's about 4 gigs in size, and you'll see here it looks like the speed's really fast to start with, but that's all down to just disk caching. And now you can see it's dropping right off, and you'll notice as it's transferring across it will actually almost seem like it stops a few times before the file's transferred. And this transfer is over to the actual physical iSCSI drive on the unRAID server. Now we can try and improve the disk I/O in the actual XML settings of the VM in a moment, but first let's just try and copy the same file across over onto the vdisk iSCSI target just so we can compare the speeds. Again, it's going to start really high due to the caching again, and then the speed will drop down, but this time the speed seems like it's quite a bit faster. Basically this is a vdisk on the SSD as opposed to a mechanical hard drive. Okay, so I'm going to delete these images now and then go back to the XML on the VM and make some changes. So let's click on Edit XML, and then we need to scroll down to where the disks are, and you can see here the cache type set to write back. Now we want to change this, so we're going to put in cache equals none and IO equals native, and we're going to do this for both of the vdisks that are attached to the iSCSI targets. Obviously we don't need to do this for the boot disk for the VM. So let's start back up the VM and run our tests again. So first we'll start with the iSCSI target on the physical drive and copy the same Windows 10 ISO. And now you can see that the speed is much more consistent. It's not really kind of stopping at all, it's just going straight the way through. So the performance I think is, a lot better. Right, now same test again but on the vdisk on the SSD. And again we can see an improvement. We can see the speeds hovering around the 100 mark all the time through the transfer. So setting the vdisk's cache to none and the IO to native definitely seems to have a positive effect on the speed. So for vdisks on SSDs and pass-through physical drives, the best performance was achieved with cache equals none and IO equals native. But now I'll show you all the various tests I did with different settings on a server with gigabit Ethernet, after which we'll set up 10 gigabit Ethernet and run the same tests. Before looking at the iSCSI results, this was the speed I was getting transferring two 3.5 GB files to and from a normal share on the unRAID server. I did this just to compare to the speed of the iSCSI targets, and both read and write speeds were around 112 megs per second. Now in all of these tests the video is really sped up, so just look at the transfer speed whilst the file is copying. It took considerably longer to transfer the 7 gigs moved in each of these tests than it appears in the video. And these tests here were iSCSI targets, all of which were on the same mechanical unassigned hard drive, tested both as a pass-through device and also as vdisks on the same drive but formatted in XFS. And you can see here that the read speeds were all about the same, but obviously the write speeds did vary a bit. My conclusions here were, using an unassigned drive, best performance was to pass through the whole drive with cache as none and IO as native. And for vdisks on the unassigned drive, the difference between raw and QCOW2 speeds were very small, and the vdisks on the mechanical unassigned drive performed better using cache equals write back. And these tests are all to QCOW2 vdisks on SSDs. I found the difference in speed between a raw vdisk and a QCOW2 VDisk was really small, so I think the advantage of being able to have a VDisk that will expand and grow in size only when it's needed is preferable to the slight performance advantage that I saw when using raw VDisk iSCSI targets. So obviously the VDisks on the SSD cache and the NVMe unassigned disk have the best performance, almost being as fast as using a normal share on the array. Now the VDisk that I put on the parity protected array, I had to use cache equals write back. If I didn't do that, the performance was absolutely terrible and really couldn't be used at all. But one thing that made a really big difference was the amount of RAM available in the server. I ran the test twice, once with 16 gigs of RAM in the server, which I had about 12 gigs available, and the other time with 64 gigs in the server, where I had 60 gigs available. And you can see the more RAM you have in the server, obviously the better the performance is using cache equals write back. Okay, so now let's try it with 10 gigabit Ethernet, so let's set that up in Openfiler. So let's stop this VM for a moment. Let's go to settings and network settings, and here's my gigabit Ethernet adapter, and underneath here this is the 10 gigabit Ethernet adapter. And I'm showing you this because I have bridging enabled and it's a member of BR1. So now I'm going to add a second network adapter to the VM, and I'm going to do that by editing the XML. So if you scroll down and find the first network adapter, that one here, let's just copy this XML here, and then underneath we're just going to paste it again. And here we're going to change the bridge to be BR1, so then it's bridged with the 10 gigabit Ethernet adapter. Another thing we have to change is obviously the MAC address, because the two adapters can't have the same MAC address. And here I've got another tab opened to a blank template for a VM. So I'm going to scroll down to its network adapter and just steal its MAC address here, because every time we open the VM manager to create a new VM, it creates a new unique MAC address. So I'm going to cancel the template anyway because I only want the MAC address, and paste it in here. And lastly, we just need to remove this address line here of the second network adapter. Obviously it will be the same if we don't. We don't need to actually put anything else in, we can just click update and the unRAID VM manager will add a new address line. So now let's start back up the VM. And let's click onto system. Now we need to set up a static IP address for our second Ethernet adapter, just the same way as when we did it when we set up the VM in the first place, but this time we just have to make sure that it's in the IP range for our 10 gigabit Ethernet adapter. And I'm going to set mine to 192.168.11.10. Okay, so now we have an address for the bridged 10 gigabit Ethernet adapter. So let's go back to our network page, and if we scroll down to the bottom, we can add the new network range to be able to access the iSCSI targets. So again, put in the network range here that corresponds to the 10 gigabit Ethernet adapter and your subnet mask, and then click on update. And also, it's not necessary, but I'm going to delete the LAN network here because I'm only going to be using that one to log into the web interface with. And let's go to volumes and iSCSI targets, and then just click allow on this new network IP range we've put in. And if you have more than one physical target, then as before, make sure you allow access for each one. Okay, so let's reconnect these iSCSI targets and let's test and see if there's any speed increase. Well, as expected, the pass-through mechanical hard drive is no faster reading or writing. Now this is because the mechanical hard drive is just too slow to benefit from the increased bandwidth from the 10 GBE. But for the VDIS on the SSD and on the array, the write speeds have just about doubled. And the read speeds seem to have remained about the same. However, I say read speeds, but what we must remember is the read speeds are also the write speeds on my client computer, my Windows box. It does have an SSD, but only a 128 gig one, so it could be down to the slow writes on that, although I would have hoped for a bit better. Now what I should have done was to set up a RAM drive on my Windows box, so there'd be no bottleneck that end. Anyway, this wasn't a video about benchmarks, it was about how to set up an iSCSI target. So let's finish on using the iSCSI target for something useful. I'm going to install a game onto it. Okay, so now I'm going to install a Blizzard game. I'm going to install Heroes of the Storm. As you see here, I've got lots of map network drives, but when we actually start the installer up and click change directory, the map network drives aren't visible because we can't install to there. So I'm going to install to this physical drive D, which is the iSCSI drive. And using this location, the game installs absolutely fine. The install's speeded up a lot, but you can see here the game's installed and now it's running. So my Windows box thinks it's local, but actually the storage is on the unRAID server. Okay, so that's the end of another video. I really hope you found it interesting, and if you did, then please hit that like button, it really helps. And if you're not a subscriber, well, why not subscribe? And if you'd like to support the channel, then any donations are really appreciated, which you can do from the links on the channel page or in the description. Anyway guys, whatever you're up to for the rest of the day, I hope it's good, and I'll catch you in another video.